Hi, third graders. This week we're continuing to talk about fractions and we're going to be focused on parts and wholes and then multiple whole numbers in a fraction. So for this video, you need a pencil, you need a paper, and you need two different colors. Pause now and go get those. Okay, so this week I'm doing something a little bit different, not anything drastic, but instead of having one long video by me and then a couple Khan Academy videos to supplement it, what I did was I took my one long video and I broke it into 3 shorter videos so that I don't need to supplement it on different days with different videos from Khan Academy. So videos will be shorter, but there will be more than one of me. So this is part 1. And we're going to be focused on basic fractions up to a whole. So as a reminder, and I want you to write this down, fractions have 2 parts right now. They've got a numerator and a denominator. The numerator represents the parts, and the denominator represents the whole. And that's where it can get confusing this week, because people always think the whole is the total number of parts, but it's not. The whole is the total number of parts in one figure or in one set. So you need to be clear on the whole is the total within one. You'll see what I mean here in a second. So here I have a figure. It's a rectangle. You already knew that. It's broken into 4 parts. This entire rectangle is broken into 4 parts, so my denominator is 4. Regardless of how much is shaded in, regardless of how many of these rectangles I have, the denominator is 4 because the rectangle is broken into fourths. So, as a review, if I would shade one part, that would be called 1/4. If I shaded 2 parts, that would be 2/4. If I shaded 3 of the parts, it would be 3/4. And if I shaded 4 of the parts, it would be 4/4. It doesn't matter how many parts are shaded, the denominator is still 4 because it's still broken into 4 equal parts. Here are some of the common mistakes I'm getting. The biggest one is I'm seeing people do this. They're saying that, okay, 2 parts are shaded and 2 parts are not shaded. That is not how you write a fraction. This is incorrect. It's the total in the whole as the bottom, regardless of what's shaded. So my bottom has to be 4 because it's broken into 4 parts. So here I have some figures. They're all exactly the same. They represent 5 different fractions, all of which are broken into fourths. Doesn't matter how much is shaded, they are all broken in to fourths. So the denominator is 4 for all of these. If you look at the first one, how much is shaded? How many parts are shaded? None. So this figure and this fraction represent literally nothing. That is 0. Anytime 0 is on top of the fraction, it's equal to 0. So you can have 0/8, 0/20, 0/10,000, 0/1,000,000th. They're all the same. They're 0. This next one, I've got 1 part shaded, so it represents 1/4. The next one has 2 parts shaded, so it represents 2/4. The next one has 3 parts shaded, so it represents 3/4. And this last one has all 4 parts shaded, so it represents 4/4, which we can see represents one whole rectangle. 4/4 equals 1. Because the entire rectangle is shaded in. One whole rectangle. The same is true here. All of these circles are broken the same way. They are all broken into 2 equal parts. We call those halves. Doesn't matter that the denominator's 2 right now because this equals a big fat nothing. This is 0. 1 part is shaded here, so this represents 1/2. 2 parts are shaded here, so it represents 2/2. 2/2 equals 1. Even though they are 2 and 2, it still equals 1. It is one whole circle. Common misconception I'm seeing right now. Kids think 2 over 2 equals 2. It doesn't. It means that I have one circle broken into 2 parts, and both of them are shaded. So it actually equals 1. When the numerator and the denominator match, something magical happens. Here I have another one. You can see these are all broken the same way. This one's broken into thirds. None of them are shaded, so it is 0/3, which equals 0. Broken into thirds, 1 part shaded, 1/3. Broken into thirds, 2 parts shaded, 2/3. Broken into thirds, 3 parts shaded. Does it equal 3? No, it doesn't equal 3. It equals 1. It is still one rectangle. That one rectangle has been broken into 3 parts. That's why the denominator is 3. All 3 of those parts are shaded. That's why the numerator is 3. But guess what? It's still only one rectangle. It's not 3 rectangles. So it equals 1. Here's what I notice. This fraction is 1 over 1. One rectangle, 1 part shaded. This one is 2 over 2. Broken into 2 parts, both of them are shaded. This is 3 over 3. Broken into 3 parts, all 3 of them are shaded. This is 4 over 4. Broken into 4 parts, all 4 of them are shaded. Broken into, whoopsie, I almost wrote 5. 6 parts, all of them are shaded. Broken into 8 parts, all of them are shaded. Do you notice something here? These all represent one rectangle. These are all equivalent to 1. What do you notice about all these fractions that are equivalent to 1? It's magic. Anytime the numerator and the denominator are the same, it's equal to 1. It could be 2 over 2. It could be 5 over 5. It could be 12 over 12. It could be 100 over 100. It could be smiley face over smiley face. It could be triangle over triangle. They are all equal to 1 because the numerator and the denominator are exactly the same. So that means it's equal to 1. Now you're going to go practice identifying fractions that are equal to 1. I'm expecting that you're going to do awesome on this because you are great mathematicians and you can see this pattern. When the numerator and the denominator are exactly the same, your fraction is 1.